So now in your notes, you have the following problem. It's time for you to try it. Put into practice all the 5 steps that I showed you. Identify what you're given in the problem. Identify the target. Where are you trying to get to? What unit are you trying to get to? What's the bridge between the 2 units? You'll see that it's written in sentence form. You need to write it as an equality. Set up a conversion and do the calculation. Go ahead and try it. As an additional hint, I'm even giving you the answer. See if you can get it using your dimensional analysis. Of course, you know I wasn't going to let you just sit there and leave you hanging like that. So here is what you need to do. Okay. Step 1, our given value for this problem is that the fuel attendant needs to add 25,000 kilograms of fuel, and we need to figure out how many liters of fuel that's going to be. That's the target. So there's step 1 and 2. Okay. Step 1. What's our given? Okay. Step 2, what are we trying to get to? Okay. Step 3 is to build that bridge. So the bridge was given to us in the problem. It told us that there were 0.81 kilograms for every 1 liter. Now because we started with kilograms, we want to put kilograms at the bottom to get them to cancel out. Whatever you want to get rid of goes at the bottom. Whatever you want to get to comes up here on top, okay? So when we multiply 25,000 times 1 divided by 0.81, we find out that we need 30,864.2 liters of fuel. That's the answer. That's all 5 steps. As a quick little review, I want you to add something to your notes that's kind of very useful for you, okay? There's a basic setup for all of this. You always start with the given. That's your step 1, okay? Your given value and unit. And then you build your conversion factor. Then you're going to build a conversion factor, and you can use a little table setup. We draw a line, and we build the conversion factor right here. And the unit we want to get rid of goes at the bottom. And the unit to get to goes on top. This can continue as many times as we need. So I'm going to put some dots here. We can have conversion factors, 5 of them strung together in a row, but you build the table here as large as you need it, okay? So we may need to keep going and have another conversion and another conversion. We'll take a look, okay? I hope this lecture helps you understand the need for learning dimensional analysis in real life. We are going to tie this back to chemistry here. Let's take a look at one last problem here, problem number 2. What if the fuel attendant made the same mistake that the attendant did with Air Canada Flight 143? Let's take a look. Instead of using the liters to kilograms, what if she went to pounds? Let's take a look at that. So we have 25,000 kilograms of fuel, and we're going to build our conversion factor, right? According to the mistake that the flight attendant made, one way of doing this would be 1.78 pounds for every 1 liter. And then run the calculation. okay? That would give us 14,045 liters, right? But do you see the error? This is very similar to what the flight or fuel attendant, I am not going to get that right, guys, I'm sorry. Very similar to what the fuel attendant did, but check this out. The kilograms and the pounds do not cancel out. So this is not a conversion that can happen. In order for dimensional analysis to work, your units here and here have to be able to cancel. So let's try it the correct way, okay? We have 25,000 kilograms, and we need to build a conversion factor. And this time now, we have to pay attention to the fact that we want to get rid of kilograms. So kilograms is going to have to come down here, okay? So we have to recall from the first problem that there are 0.81 kilograms for every liter of fuel. So now we're going to take our 25,000 kilograms times 1, divide by 0.81. When we do that, we get a final answer of 30,864 liters of fuel. We'll talk more about this stuff in class.